Alright, this is a review about simplifying radicals. Basically, there's a lot of different ways to do this, so I hope that this way is understandable to what you might have done in the past. First thing I like to do is take the coefficient of 27 and make a prime factor tree out of it. 7 would be rewritten as 3 times 9, and 9 is 3 times 3. So I know 27 can be rewritten as 3 to the third power because there were 3 3's multiplying each other to get 27. To the third in here. Okay, the next part of this has to do with dividing the exponents by your index, which since it's a square root, your index would automatically be a 2. So I'm going to divide this exponent of 3 by 2. I'm going to divide this exponent of 2 by 2. And so let's go ahead and see what that does. On the first part, when I divide 3 by 2, it is with a remainder of 1. So that 2 divided into 3 comes to the outside. The remainder of 1 remains on the inside. So 3 divided by 2 is 1 with the remainder of 1. Now I'll do it with the k squared next. So 2 divided by 2, still taking the square root, is 1. And there is no remainder. So it's going to be 3 to the first, k to the first, times the square root of 3 to the first is my final answer. So I'm basically going to go through that process yet again. 147, going to write it as a prime factor tree. 2 does not go into it, 3 does, 49 times, and 49 is 7 times 7. Now that I've got that, I can actually rewrite the 147 as 3 to the first times 7 squared. So the square root will be of 3 to the first times 7 squared times 7 cubed. Now I'm going to divide every single one of my exponents that I can. 1 cannot be divided by 2. So that I know 3 to the first is going to be inside the root. 2 divided by 2 is 1. So I know 7 to the first is outside of my root. No remainder. 3 divided by 2 is 1 with a remainder of 1. So into the first outside, into the first inside. 7n times 3, square root of 3n is my answer. Now, because I've taught it this way, whenever we start doing a cube root, it's actually no more difficult than the square root. So it's the same process every single time. Let's write down the 128 out to the side here and make a prime factor tree out of it. So that would be 2 times 64 would be one that comes on. 64 would be 8 times 8, and each 8 times 8 would be 2 to the third power, so 2, which is 2 times 2, 2 times 4, which is 2 times 2. So while it might look like a lot, here's my prime factors, a bunch of 2's. So 1, 2, 3, 4, 5, 6, 7 2's, 2 to the 7th power. Alright, now I'm going to write that cube of 2 to the 7th power, v to the 7th power, and exponents by 3. 7 divided by 3 is 2 with a remainder of 1. So 2 will be to the second power outside. There will be a remainder of 1 inside the cube. 7 divided by 3 was 2 with a remainder of 1. Now for the v, it's actually the same thing. 7 divided by 3 is 2 with a remainder of 1. So my final answer, I'm going to simplify as 2 squared, will be v squared times the cube root of 2v for this problem. So on the fourth of 10 problems, by the way, is what I'm showing you on this video. We're going to have the cube root of 216. So with 216, I'm going to make the prime factor tree. I know 2 goes into it 108 times. I know 2 goes into that 54 times. For 54, I know that's 9 times 6. 9 is 3 times 3. And 6 is 2 times 3. So here's my prime factors. So 2 will be to the third power. 3 will be to the third power. So now I'm going to write that inside my Radican. So the cube root will be of 2 to the third times 3 to the third times x to the 8th from the original problem. Now I'm going to divide my exponents. 3 divided by 3 is 1, so 2 to the first outside. 3 divided by 3 is also 1, so 3 to the first outside. 8 divided by 3 is 2 with a remainder of 2, so it's going to be x squared outside times the cube root of x squared inside. Again, 8 divided by 3 is 2 with a remainder of 2. At this time, I'm now going to multiply the 2 and 3 together. 2 to the first times 3 to the first is 6. X squared times the cube root of x. And that's your final answer. So at this time, if you're feeling pretty comfortable, the rest of these problems are going to be more of the same. You can go ahead and do your assignment, but come back and look if you're having some issues. But I am going to carry these out just so you'll have more examples to view. So I'm going to take the 512, make a prime factor tree out of that. So 512 will be 2 times 256. If you need a calculator through this portion, that's completely understandable, because even I mess up sometimes. I know 256 is divisible by 2. So now I'm going to go ahead and say that 256 would be 128 if I divide it by 2. And 128 is 2 times 64, and we've seen this one before. That's 8 times 8, which is 2 times 4, 2 times 4, and 2 and 2 and 2 and 2. So now we just got to count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, wait. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. So 2 to the 9th. So this is actually, what that means is 512 is a perfect cube, since 9 will be able to get divided evenly by 3. Alright, so now 9 divided by 3, that will result in 2 to the 3rd power. 7 divided by 3 is 2 with a remainder of, and 2 divided by 3 cannot be, so I'm just going to leave y squared inside this cube root. And the last thing I would do here is actually say 2 times 2 times 2 would be 8 to wrap this problem up. This is problem number 6 of 10. 92, prime factor is 196. 2 times 98. I'm definitely using a calculator around, y'all just don't see it. I guess you could actually. So there's where I actually just said, alright, 392 divided by 196 divided by 2 to see what these would give me, since I know that 98 is divisible by 2, so 2 times 4, and 49 is just simply 7 times 7. Alright, now I'd represent that as 2 to the 3rd power times 7 squared. Well, I plug it in over here. So the square root of 2 to the 3rd power times 7 squared, a squared, b squared. Now I'm just going to divide my exponents. 3 divided by, again, square root, so that's an index of 2 here. So 3 divided by 2 will be 1 with a remainder of 1. 2 divided by 2 is going to be 7 to the 1st power. 2 divided by 2 is going to be a to the 1st power. 2 divided by 2 is going to be b to the 1st power. Now that I've done all that, I can simplify 2 times 7, which is 14. A to the 1st power, b to the 1st power, square root of 2 to the 1st power is my final answer. Alright, so on this problem we're back to cube rooting. So take the 162, make your prime factor tree. 2 goes into it 81 times. 81 is 9 times 9, which is 3 times 3 and 3 times 3. So now I'm going to represent it as 2 to the 1st times 3 to the 4th power for my prime factors. I'm going to put that in right over here. The cube root will be of 2 to the 1st times 3 to the 4th times a to the 8th times b to the 1st. Now I'm going to start dividing my exponents again. 1 divided by 3 cannot be divided, so it's going to be the cube root of 2 to the 1st, since I could not divide 1 by 3. 4 divided by 3 is 1 with a remainder of 1. 4 divided by 3 again is 1 with a remainder of 1. 8 divided by 3 is 2 with a remainder of 2. And b to the 1st, 1 divided by 3 is not going to divide, so it's just going to remain inside here. So as my final answer, I have 3a squared times the cube root of, go ahead and make this 2 times 3 is 6. inside here. If ever there's an exponent other than 1, you would want to apply that exponent first, then multiply. A squared b to the first. And that wraps it up. I've even got fourth root thrown in here, but it's going to be the same process. So 96 is the same as 2 times 48. 48 is 2 times 24, which is 2 times 12, which is 4 times 3, which is 2 times 2. If ever you're getting frustrated with me for how I'm making my prime factor tree that would be different than yours, it's fine. You should end up with the same prime factors. There are 1, 2, 3, 4, 5 2's and 1 3. Now I'm going to place that in here. So the fourth root will be of 2 to the 5th power times 3 to the 1st power times m to the 5th power times n to the 4th power. Now I do all my divisions. 5 divided by 4 is 1, and there will be a remainder of 1. 3 to the 1st, 1 divided by 4 will not happen, so it's going to remain inside. 5 divided by 4, that's m to the 1st power and a remainder of 1. 4 divided by 4, that'll be n to the 1st power outside. There is no remainder, so n will not be in here. At this time, let's go ahead and just rewrite this. 2 to the 1st, m to the 1st times the fourth root. 2 to the 1st times 3 to the 1st will be 6, m to the 1st. Alright, here's my next to last one. 40 can go to 2 times 20. 20 is 2 times 10. 10 is 2 times 5. So I'm going to rewrite the 40 that's in this cube root as 2 to the 3rd power times 5. And I'm going to go ahead and keep all, and 5 is to the 1st power. M is to the 6th, n is to the 6th, p is to the 3rd. Now I'll start dividing. 3 divided by 3 is 1, so 2 to the 1st outside. 1 cannot be divided by 3, so it's going to be the cube root of 5 to the 1st is going to remain inside. 6 divided by 3, m is to the 2nd power. 6 divided by 3, n is to the 2nd power. 3 divided by 3, p is to the 1st power. So 2 m squared n squared p to the 1st times the cube root of 5 to the 1st is my final answer. You gotta love how complicated this is. Alright, finally wrapping up with my last one here. 147 clearly can't be divided by 2, but it can be divided by 3, which goes into it 49 times. 49 is 7 times 7. So I'm going to rewrite the 147 as 3 to the 1st times 7 squared. I still have x to the 4th, y to the 1st, z to the 2nd. Now I'll start dividing. Remember, your index is 2 if it is not written. So 1 divided by 2 cannot be divided. So I'm going to have square root of 3 to the 1st still. 2 divided by 2, 7 to the 1st power. 4 divided by 2, x to the 2nd power. 1 divided by 2 cannot be divided, so y to the 1st power inside here. 2 divided by 2 is z to the 1st power outside. So 7 to the 1st power, x squared, z to the 1st power times the square root of 3 to the 1st power, y to the 1st power. Alright, that wraps it up. Please let me know what questions you have. Thank you.